Question 57. Well, base your answers to question 57 to 59 on the cross-section below, which shows two weather fronts moving across New York State lines. Lines X and Y represent frontal boundaries. Question 57 through 59. Base your answers to question 57 through 59 on the cross-section below, which shows two weather fronts moving across New York State. Lines X and Y represent frontal boundaries. The large arrows show the general direction the air masses are moving. The smaller arrows show the general direction warm moist air is moving over the frontal boundaries. Question 57. Which type of cold front is represented by X? So here's it says, shows you an arrow and CP. CP, if you look at your graphs that they give you, it will show you that C is continental, P is polar, CP is continental polar. Continental is going over land, so it's dry. Polar is from the pole, so it's cold, dry air. So it's moving this direction. So this whole thing, anything that's under this, the X line is like a mountain over here. So it's a cold front. And the question is, which type of front is represented by X? Well, X represents this front over here. That's inside X. So the answer to 57 is a cold front. Question 58. Explain why the warm moist air rises over the frontal boundaries. Well, this is CP, this boundary of X, and Y is also CP. CP is continental polar. Continental is dry, polar is cold. So first of all, if it's cold air, the molecules are more squashed together. So when everything's more squashed together, it becomes more dense. Something that's more dense is more heavy. The warmer it gets, the more the molecules spread. And the more they spread, the less molecules are in one spot. So the less dense that area is, so it's lighter. So the cold front, the air stays down because it's heavier, because the molecules are squashed together. And in the middle, you have MT. MT is maritime tropical. Maritime is moist, because that's over the water. So it picks up moisture. And moist air, dry air, which is over continental. Dry air has molecules of nitrogen and oxygen, which are heavier than molecules of water. The moist air has molecules of water mixed into the nitrogen and oxygen molecules. So therefore, since you have lighter molecules mixed up with heavier molecules in the moist air, and in the continental ones, you don't have the moisture, so you don't have the lightness, so the continental stays heavier, and the maritime, which is moist, is lighter, plus tropical means near the equator, so it's warmer than the P for polar. CP is continental polar. Over here also, CP is continental polar. So first of all, the question is, why is the warm air rises over the frontal boundaries? The reason is because the two frontal boundaries are continental polar, and the warm moist air is lighter. So you could answer it in many ways. The easiest way is just to write the warm moist air is lighter than cold dry air. And if you want to explain on it, you could say because dry air has molecules of oxygen and nitrogen, which are heavier than molecules of water, and the maritime tropical, the warm air over here is maritime, so it has liquid in it. It has molecules of water which make it lighter. So therefore it rises above the cold fronts, the cold front that's coming towards it and the cold front that's moving away. And also because it's tropical, it's near the equator, the warmer the area, the more the molecules spread out, and the less molecules in one area, so the less density means less weight. So since this is MT, maritime, it's moist, so it's lighter than continental, of going over land, which is dry, and it's tropical, so it's warmer than the polar ones that come from the poles, the North Pole and the South Pole. So therefore, they rise. So the question again, explain why the warm, moist air rises over the frontal boundaries is because warm, moist air is lighter than cold continental air. Question 58. Explain why the warm, moist air rises over the frontal boundaries. Well, it's warm and moist, and these frontal boundaries, it says CP. CP, we know, C is continental, which means over land, so it's dry. Polar is from the poles, so it's cold. CP is cold and polar. It's continental and polar, dry and cold. So the drier the air, the heavier it is, because the molecules squeeze together more. Polar, that's if it's dry. If it's Question 58. Explain why the warm, moist air rises over the frontal boundaries. Well, the warm, moist air is in the middle, and you see that it's rising. And here are the boundaries. Here is CP, which is continental polar. And over here is CP, which is continental polar. Continental polar means continental is over land, so it's dry. The drier the air, the heavier it is, because it has the molecules in dry air are heavier than the molecules in moist air. And polar, the colder it is, the more the air squeezes together, the more the molecules squeeze together, the colder it is, the more molecules you have in one spot. And the more molecules you have in one spot, the heavier the air is. So continental and polar means dry and cold. There's two reasons why the air is heavy. Now maritime, tropical, maritime is moist. Moist air is lighter than dry air. The moister it is, the lighter it is. And tropical is warm. Tropical means near the equator. So warm air is lighter. The warmer it is, the lighter it gets. And moist is also, the moister it is, the lighter it gets. So therefore, the answer to question 58, you just have to write warm, moist air is lighter than cold and dry air. Warm is lighter than cold, and moist is lighter than dry. But all you have to write for this is warm, moist air is lighter. Question 59. Which type of front forms when front X, that's this arrow that shows everything underneath the X, catches up and overtakes front Y? That means this cold front is moving in this direction. What happens if the cold front above, beyond it, you have a warm front in between the two cold fronts? And if the question 59, which type of front forms when front X catches and overtakes front Y? So we know that front X is a cold front because CP is continental, polar is cold, and front Y is also cold front, continental, polar is the poles, which are cold. So what happens if this front catches up, which is a cold front, and overtakes the other cold front? Well, what's in between the two cold fronts? A warm front. So we know that warm air goes up and cold air goes down. So if the cold front will catch up to the other cold front going in the same direction. In other words, this cold front is, let's say, going 50 kilometers an hour or 50 miles an hour, and this one is going 100, and it catches up to it. So all the warm air will rise. And if it catches up, all the warm air on the way will lift off the ground. So this cold front, when it catches up to the next cold front, it will lift up all the air of the warm front. When that happens, it makes an occluded front. And the occluded front is when a cold front lifts a warm front off the ground. So that's what this is going to do. The X cold front, when it catches up to the Y cold front, so everything over here, all the warm air over here is going to be lifted off the ground and been overtaken by the X. So that will be an occluded front. So the answer is an occluded front. That's OCCLUDED, front. An occluded front is the answer to question 59, is an occluded front.